Welcome. I'm glad you joined us. We are going to take and use an example to show how to write the equation of an exponential function that contains solution points that are given to us. And we want to write the answer in f of x is equal to a times b to the x form. To do this, what we are going to do is first take our function f of x equal a times b to the x form and one of our ordered pairs to start with, and make some substitutions to generate an equation with just a and b. So first of all, what we want to do is look at what happens if we take out the x and put -2 in its place in this form. Well, that would give me a times b to the -2 power. Now, let's look at what it means for the ordered pair. Well, the ordered pair is telling me that if I have our function and I put -2 in for x, I will get out a 25/48 for the output. Well, that means then that these two quantities are equal. So I have a times b to the -2 is equal to 25/48. Now we are going to go to the other ordered pair and do the same process. So we start with our f of x is equal to a times b to the x. F of 2 is a times, we'll take out the x and put in 2, so a times b squared. But from the ordered pair, I have that a of 2 is equal to 27/25, the output of that ordered pair. So then I get the equation that a times b squared is equal to 27/25. So now I have these two equations that I want to solve. A times b to the -2 is 25/48. And a times b squared equals 27/25. Now these equations are not linear, but I can still solve them by substitution. Let's take this first equation and solve it for a. So remember, b to the -2, well, a negative exponent is a reciprocal, so that's a times 1/b squared is equal to 25/48. Multiplying both sides by b squared, I get a is equal to 25/48 times b squared. And that 25/48 times b squared, we are going to replace in the a of this other equation. So that gives us 25/48 b squared, and then times the b squared, that is the other factor in the equation we're plugging it into. So that's the a that we plugged in, and then times the other factor that's there, and that equals 27/25. Well, this gives me 25/48 times b to the 4th is equal to 27/25. Solve for b to the 4th by multiplying both sides by 48/25, and I get b to the 4th is equal to 1,296/625. Now we want to take the 4th root of both sides to solve for b. And remember, when we do that, we have to remember the plus or minus. So our b is equal to plus or minus 6/5. However, if you recall, b is the base of our exponential part of the function, and the base of an exponential function has to be positive. So for this, we are only going to consider the positive. So we'll just go ahead and erase the minus off of that. So that's our b. b is equal to 6/5. Next up, we still need to find a. So we can go to any of these equations that we have for what a is equal to and solve for the value for a. We are going to look at the part that's highlighted in green. So we have a is equal to 25 over 48. And notice that's times b squared. So we're going to take our 6/5 squared. And this gives me a is equal to 25 over 48 times 36 over 25. And that simplifies to the value of 3/4. So now we have our a and we have our b. Our function f of x is equal to a, which is the 3/4, times b, which is equal to the 6/5 to the x power. And that's how you write the equation of the exponential function when you're given 2 points that it contains.